whenever you graph, what's the first thing you should always do? Get the y by itself. Excellent answer. So getting the y by itself, what do we need to do? Subtract 3x. So that would be y is equal to 12 minus 3x, or negative 3x plus 12, if that's your prerogative. I know a lot of people really like for the slope to come first, so you could have done that. Yeah, divide by 2. And what's that be? Y equals 6 minus 3 halves x, or negative 3 halves x plus 6, if that's your thing. Now, to graph that, let's see. Does anybody need me to leave that work on the board for a moment? Okay. To graph that, and by the way, hope you have your homework ready, because we are going to be putting some of those on the board in just a moment. You needed to y-intercept of 6, 1, 2, 3, 4, 5, 6, ka-chow, and a slope of negative 3 halves, down 3 over 2, oops, connect the dots, and thereabouts should be your graph. Down 3 over 2 is the slope, so that's what you should have done. Questions on that one? We're actually going to be talking more about this, Dom, in just a minute, but before that, so here's the little wrinkle we're going to add in there. I believe just a second ago I had that line, correct? Well, today, everything's going to be the same, except, well, this isn't a very good drawing, but you get it. Today we're going to change what we're doing, and instead of an equal sign, we are going to have an inequality. We're going to be graphing inequalities, but you're going to graph them the same way. And here's how that's going to work. Let me show you a quick little example. In fact, let me just do this one, but with the inequality instead of the equal sign. Here's how this is going to work. You're still going to graph it the same way. You're still going to have to solve for y, and we've solved inequalities before. We've done this already. Remember, when you have to divide and multiply by negative, you got to flip your inequality, so don't forget that. What was this when I solved it? Who has the DOM? What was the equation when I solved it? I don't feel like doing it again. It was y negative 3 over 2x plus 6. You're going to do everything the same way, the same exact way. 1, 2, 3, 4, 5, 6. Still a slope of negative 3 over 2, except here's really the only two differences. Does this have an equal sign on it? No, some inequalities have the equal sign with it, don't they? Yep. And in that case, let's say for a second that was less than or equal to, you would graph it the exact same way. If it had an equal sign on it, you would literally graph it the same way. If it does not have an equal sign on it, then you're going to make it a dotted line, like that. I should be able to look at your graph and tell what your equation was. For instance, I should be able to look at your graph and be like, oh, y-intercept of 6, slope of negative 3 over 2. Oh, it's dotted. That means it was no equal sign. It was just less than or greater than.
So, if it's less than, can it be negative?
Well, I haven't talked about that part just yet. That's a good question. No. If it's, let me erase something real quick. All right, to answer your question, here's where the less than and greater than comes in. The difference between less than or greater than. If it's less than, you're going to shade below the line. And if it's greater than, where do you think you're going to shade? Above the line. Yeah, that's the whole thing. The only, oh, awesome. Only two differences. If there's no equal sign, it's dotted instead of a whole line. And if it's less than, you shade below. If it's greater than, you shade above. In this case, y was less than. It's always if y is less than. Y is less than, so we shaded below. If y was greater than, we would have shaded above. Now, if you're wondering, why the heck would we bother doing that? Here's why we would bother doing that. Let's take a look at this problem. From the set of those four numbers, which ordered pairs are part of this solution set? Hey, that looks familiar. That's what we just graphed. which ordered pairs are part of that solution? Now, here are two ways you could do this. One, graph them. If you graphed that line and shaded it like we just did, and then plotted all 4 points, point, 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 the points that are in the shaded region are in your solution set. The points that are not in your shaded region would not be in your solution set. Because everything that's shaded means that those coordinates work in that inequality. Now, of course, the easier way to do it, just plug the dang things in. Let's plug in 1 for x, 6 for y. So, if we did that for the first one, that'd be 3 times, whoa. That would be 3 times 1 plus 2 times 6 is less than 12. Is 3 plus 12 less than 12? No, it's 3 plus 12 would be greater than 12. So this is false. So that one's not in there. What if we try the second one? 3 times 3 plus 2 times 0 is 9 going to be less than 12? Yes, that one worked. This one didn't. Before we go on to the next two coordinates, raise your hand if you have a question about where I'm getting these equations.
Are you just plugging in the ordered pairs?
Yes, I'm plugging in x and y into that equation right there. That's exactly what I'm doing. So, first one worked, second one didn't. We could try 2, 2. 3 times 2. Yeah, I said it backwards.
Number of ordered pairs, like, is it going to be 2 out of each set or just any random?
It could be any random. It could be 1, could be none, could be all 4, etc. That's a good question. Let's see. So, is 6 plus 4 less than 12? Yes, it is. So that coordinate worked. Last but not least, 3 times 4 plus 2 times 3. Is that less than 12? No. No, it is not. So, your answer is, which ordered pairs worked? That would be 3, 0 and 2, 2. Now again, let me stress, on a graph, does everybody have this written down who wants it? On a graph, and I'm just going to quick sketch it again, this is what this would have looked like. If we had done our line, just like we did last problem, except it would have a break in it because, alright, if we had done our line and then shaded below, here's what this would have looked like. The 2 points that did work would have, well, that's a really bad point, would have been in the shaded region, and the 2 points that didn't would not be in the shaded region. That's what it's going to look like on the graph, because the shaded region is all the points that would satisfy our inequality.
So that line would be anywhere?
My dotted line?
Yeah, where would you go?
Well, I graphed it twice in the DOM. I just didn't feel like doing it again. Yeah. Alright, so let's look at another one. Alright, we're going to work on graphing these. Like I said earlier, nothing changes about how you graph these. Nothing.
So,
First,
since that's an equal sign, you can... It's the exact same as the ones we've been doing, right? With the
Yep.
equal sign?
you still just have to shade when you're done. Yeah.
Can we get y by itself?
Yes, and what's the first step to doing that? Add 2x. So that's y is less than or equal to 2x minus 4 or 4 minus 2x, whichever way you'd prefer to write it. Y is by itself, so we're good. We did not have to flip the inequality because we did not multiply or divide by a negative number. So you go down to your y-intercept, 1, 2, 3, 4, and you do your slope of 2. Up 2 over 1, up 2 over 1 again. Is it going to be a whole line or a dotted line? Whole line or dotted line? Whole line. Why is it a whole line? Because it has an equal sign. That's right. Whole line, because it has an equals. And is y less than or greater than? Y is less than, so we shade below. Yes, ma'am. What is what? Do you get how we got this equation? So do you get where the line came from? Y-intercept of negative 4, slope of 2, up 2 over 1, up 2 over 1, connected the dots. Just like we've been doing with the lines on those boards on Monday. We graph it the same exact way. The only thing that changed with this and graphing a normal line with slope-intercept is that you have to shade because of the inequality. If y is less than, then you shade below, but if y had been greater than, you would have shaded above. We're going to do another one. We'll do another one. In fact, I'll let you try another one, and then we'll compare. Try this one. Try this one. Herbert. Let's see. X minus 4x minus 2y is less than 8. Try graphing that thing. Resume recording. Solving for y. Darn it, why do I keep doing that? Solving for y. It was 4x minus 2y. What was it, less than 8?
Yeah.
Okay. So we minus 4x. So it'd be negative 2y is less than 8 minus 4x, or negative 4x plus 8, whichever way you preferred. Divide everything by negative 2. But because we're dividing by a negative, we have to flip our inequality. So y is greater than negative 4 plus 2x, or 2x minus 4. Then we had to graph that. Let's see, y-intercept of negative 4, slope of positive 2, and then it is a dotted line because there was no equal sign, and y is greater, so we shade above it. Very good. So that's what yours should look like. Questions? All right, let's look at another example. Again, we don't have to go through all these. You can either graph them or do what with these? If you're determining which ordered pairs are part of the solution set, what do we have to do? What's that? Yeah, plug them in, work them out, just see which ones make it true statement, which ones make it a false statement.
So you don't have to graph them?
No, you don't have to graph anything unless it says specifically to graph. For these, you could graph them, or you could just plug them in. Now let's ask a theoretical question for a second. Let's say you had one. Let me see if there's one like this on the board. No, there's not. Let's take this equation. Let's say we had one. We'll just use this equation. Y is greater than 2x, and let's say they gave us the point 6, 3. Oh, no, got that backwards. 3, 6. Now, if we plug that in, what would it give us? If we plugged in 3 for x and 6 for y, what would that say? Is 6 greater than 6? No. No, it is not, so that would be false. What about now? Yes, because 6 equals 6. Now the point of that is, if you were to graph this, and I'm just going to really quick just sketch this. If you were to graph this, that should be a dotted line, because my original was not equal to. The point is, when you graph this, the point 3, 6 is somewhere up here. If it lies on the line, if your point lies on the line, like let's say you chose to do this by graphing. If you lie on the line, if it's a dotted line, then technically it wouldn't be in your solution set, just like it wasn't a second ago, because 6 doesn't equal 6. If it's on the line and it's dotted, it's not a solution. But if it's a solid line and it's on the line, then it is. Just like the difference between no equals and with an equals when we were just looking at it a second ago. Does that make any sense? Because without the equal sign, 6 is not greater than 6. But with the equal sign, 6 is equal to 6. So the dotted or whole line makes the difference about if your point lies on the line, whether or not it's part of the solution or not. Okay. Now, before I even look at the directions, let's just look at this for a second. You should be able to tell the exact function by looking at the graph. This one, what's the y-intercept? 2. And is the slope positive or negative? Positive. And it looks like it's what? Rising 2 over 1? So, and it has an equal sign in it because it's a whole line. This equation was, and I'm not looking at that. Well, actually, let me write it down. You don't have to do this, but I'm showing you how a graph can tell you everything you need to know. This equation was y, oh, dadgummit. Y, now did it shade below or above? Below. Less than and equal to, because it's a whole line, 2x plus 2. Well, just by looking at the graph, I knew exactly. Y-intercept, slope, shaded below, so it's less than, and a whole line equal to. This one, what's the difference between these two? Just in the equation. Which means this one, when we did the equation, wouldn't have a what?
Equal sign.
It wouldn't have an equal sign. What's the difference in these two? Yeah, where it's shaded, so this one's less than, but this one would be greater than or equal to. Again, all the details you need are in the graph. So anyway, looking at the problem, what would we have to do to know that specifically? Y by itself. So that would be y, if you add the 2x, it'd be y is greater than or equal to 2x plus 2. Okay. So slope of 2, well they all have the same slope and intercept, but it's a whole line, so it had to be one of these two, and it's shaded above, so it is B. You're going to have some like this in your homework. They're matching problems, where you have to match the equation to the graph. So, B. Is there a question about any part of those that thinking process that we used right there? You're going to have to solve for y sometimes before you can start matching. Alrighty, I think I've only got maybe one more slide. And it's just graphing. I'll look at one of these with you, and then I'll let you pick to see if we look at any more. Let's look at number 7. A lot of people still get confused, and very rightfully so, they can be confusing, about if there's just one variable. Who can tell me what they believe to be a secret to graphing something with just one variable?
Would that be x0?
So many people. It will be horizontal or vertical. You could think of it as 0x, but it's really easier than that when you're just doing graphing. The easiest way to do it is just go to 4 on the y-axis. So wouldn't that be 1, 2, 3, 4 right here, right? That's 4 on the y-axis. And you're going to go straight through that point. So in this case, it would be a horizontal solid line because there's an equal sign. If that was x is greater than or equal to 4, we would have gone to 4 on the x-axis and gone straight through it that way. That's the easiest way to do it. Whatever letter's there, you're going to go through that axis. But let me erase that because that wasn't what the problem was. Now, we've graphed it. Do I shade above or below? Above, right. Shade above. If it had been x equals 4 and been this line, greater than, do you think that's to the right or to the left? Yeah, because there's no above or below. It'd be to the right. What?
Would it be a dotted line?
Yes, well, yes. Well, I was saying if x was plugged straight into this equation instead of y, so it would be an equals. But yeah, the way I said it, I said x is greater than 4, so yeah, it would have been dotted. But yeah, greater than is to the right, less than is to the left, only when it's straight up vertical. That's the only time you really think about it like that. All right, we've done number 7. Would you like to see 8, 9, or 10 worked? And do any of them that you want? Cool. Then there you go. That is 12, 14, 16, 7. I think that's 11 problems.
No, there's no big one.
Well, you can share with someone today. So make sure you get that written down. I'm going to post this video online.